Alright guys, here is our next example. So again, staying with applying radical transformations. So similar to the last example video that we did. However, this is a bit different. They tell you the parent function is the square root of x, and they want you to apply the following transformations. So essentially they want you to create a new function here, and they give you a list of transformations that took place. Okay, as we go through this, I left this little key over here in case you need that. Alright, again, if you have a strong base in linear transformations, you most likely don't need it. But again, we'll leave that over there if you do. Okay, so here we go. The parent function, f of x equals the square root of x. And then they say the following transformations were applied to it. It says stretched horizontally by a factor of 2, reflected across y-axis, and shifted 3 units to the left. Alright, so we're going to start out with our parent function. We're going to apply these transformations, and we'll essentially have a new function at the end. Alright, so since we're creating a new function, we're going to call this g of x. Alright, you could call it whatever you want, but since this is being called f of x, just don't call it f of x. Alright, so we're going to say the first transformation here, stretched horizontally by a factor of 2. So we're talking about a horizontal stretch. If you look at your cheat, your little key over here, right, horizontal stretch or compression, that's going to be your 1 over b. And we're saying by a factor of 2. So that factor of 2 is going to be your b value. So that's going to go where your b value is. So we're going to have the following here. We'll have the square root of 1/2, and then we're just going to have parentheses x here. Okay? Let's look at what we have next. Reflected across the y-axis. So remember, when we want to reflect something across the y-axis, we simply just make the x negative, right? So that's what we're going to do here. So I get 1/2, then times negative x, and then let's just multiply that out. So we get the square root of negative 1/2 x. Alright, so that is where we're at so far. Alright, the last transformation, shifted 3 units to the left. So this is being shifted 3 units to the left. So remember, we're talking about a horizontal shift here. So it's always opposite of what you think, right? So since we're going to the left, we're actually going to put in a positive 3. And again, that makes sense because we know it's really negative 3, but if you were to go ahead and put it into your equation here, right, this is for a horizontal shift. If you put in a negative 3, 2 negatives are going to be positive, hence why it's always going to be opposite of what you think. Right? So that's an easy way to remember when you're dealing with these horizontal shifts. It's always opposite of what you think. So we're going to put in the following. We have g of x equals the square root of, and I'm going to go ahead and isolate this x. I'm going to pull out that negative 1/2, and then we're just going to have x plus 3. Okay, notice how it's all underneath the radical. Okay, and this is now complete. Alright, so this would be your final answer here. Alright, so that is it. Alright, let's try another example. Alright guys, so here we go with our next example. So same thing, they give us the parent function square root of x, and they want us to apply the following transformations. Okay, so let's go ahead and read them. It says reflected across the x-axis, stretched vertically by a factor of 2, and translated 1 unit up. Okay, so let's go through each one of these transformations, and then we'll have a new function at the end. Alright, so the first one is reflected across the x-axis. Alright, so remember, when you want to reflect something across the x-axis, right, you simply make the y value negative, right? So in this case, right, think about what's going to happen here. If we have our parent function, f of x equals the square root of x, we're going to make the y negative. So we'll have this, negative f of x equals the square root of x. However, we can't leave that negative there, so we have to divide both sides by negative 1. So we'll have f of x equals negative square root of x. So notice how the negative is out in front. Okay, so when you see that, you know that you're dealing with a reflection across the x-axis, right? It's out in front. Alright, so we just proved that. So what we're going to do here is leave this like that. However, we're going to call this g of x because we're creating a new function here. So we'll call this g of x. Okay, so that is going to be our first transformation. Alright, Next one, stretched vertically by a factor of 2. So we're talking about a vertical stretch, so that's going to be our A value, and they're telling you by a factor of 2. So we're just going to put a 2 there, so we'll have this now. We'll have g of x equals negative 2 square root of x. Okay, and then the last one says translated 1 unit up. Okay, so this is going to be a vertical shift, right? Translated 1 unit up, so that's our k value. But notice how it's not underneath the radical. That's important, right? So we'll have our final answer here of g of x equals negative 2, and then we'll have the square root of x. And then make sure it's not underneath the radical. We're going to put plus 1. Right? And this answer is now complete. Okay, so that's how you go about applying radical transformations.